Welcome to Power Electronics Lab number 6, Unipolar and Bipolar PWM inverters. The objectives of this experiment are to understand, simulate, and validate the theory of a PWM for a single-phase voltage source inverter using unipolar and bipolar switching techniques. An inverter generates an AC voltage from a DC voltage with the help of switching circuits. Different topologies can be used to perform this task. Today we'll be using full bridge inverter. A full bridge inverter consists of two legs with two switches in each one of them. Those switches are connected in series. The term SPWM stands for sinusoidal pulse width modulation. That is a technique used to generate pulses for switches of an inverter. In this scheme, a sinusoidal modulating voltage of the desired output frequency is compared with a triangular carrier waveform that has a higher frequency. Amplitude modulation ratio, also known as modulation index, is the ratio of the magnitude of the modulating voltage and the carrier voltage. It has a value between 0 and 1. The modulation index greater than 1 is called overmodulation. The full bridge inverter can be either bipolar or unipolar switched. The unipolar modulation normally requires two sine waves, which are of the same amplitude and frequency, but 180 phase shifted. The two modulated waveforms are compared to the carrier waveform, while the bipolar modulation normally requires one sine wave modulating signal, which is compared to the carrier waveform. The waveforms of VAB across the load at the output of the inverter switches between positive and negative DC voltage, and hence this scheme is called bipolar PWM. This figure shows the CMOS model of a single-phase unipolar H-bridge inverter, while this figure illustrates the simulated circuit using bipolar switching technique. The fast Fourier transform FFT is an important measurement method. It converts the signal into individual spectral components and thereby provides frequency information about the signal. The FFT is one of the features integrated in the Power GUI block. To use this feature, the following steps should be followed. First, open a scope, then open Settings. In the pop-up window of the Settings, click on Logging tab, then activate Log Data to Workspace. Once activated, give a name to your variable and change Save Format to Structure with Time, then click OK. Now double-click on the Power GUI block and select FFT Analysis feature from Tools tab. Select the variable from the name list. Select FFT window and display section. Write the number of cycles and the fundamental frequency of the signal. Write the maximum frequency, which represents the window where to display requested harmonics under study. Under Display Style, select either List or Bar, then hit Display button. Thank you for watching the video.